about this one. Okay, let's look at the next problem. Next problem is a little tougher. What's going on in the next problem?
Acid.
Okay. Yeah, we've got nitric acid. Is nitric acid strong or weak?
Strong.
It's strong. Okay. So that tells us something. That tells us something. A strip of copper. So we've got solid copper. We're putting it into a dilute solution of nitric acid. The word dilute here means that we're going to have nitrogen monoxide as a product. If it said concentrated, we would have nitrogen dioxide. So make a note of that. If you see dilute, all nitric acid dissociates. Anytime you see nitric acid, yay, because it's going to completely dissociate in solution. The difference in dilute and concentrated are the products that you get. Dilute, you get nitrogen monoxide, NO. For concentrated, you get nitrogen dioxide, NO2. And again, this is one of those that if you put NO2 and it says dilute, if you can balance it, they'll give you the points for it. It's a reasonable answer. This, my friends, is a redox problem. We're going from copper with a 0 oxidation charge. We're going to put it in an acidified environment, and we're going to get copper with a 2+ charge. We're going to have water as one of our products. We're going to have hydrogen ions as our reactant. Let's try to write this out. If you can remember, this is going to take a lot of balance. If you can remember and recognize that this is a redox problem and that the product from dilute nitric acid is going to be NO, then you can write it in this way. If not, then you're going to need to put it into 2 half reactions. I like to leave it like this because I remember that dilute yields NO. And so I can predict products in that way. Here is our solid copper. Here is our nitric acid dissociated. Okay, the reason I can't cross off the nitrate part is because my product is not nitrate. My product is nitrogen monoxide. So this little thing right here, remember it because it really helps set up this equation. I have hydrogen ions over here. I have to have water over here. If you have hydroxide ions on the reactant side, you're going to have water as a product. If you have hydrogen ions as a reactant, you're going to have water as a product. That's easy to remember. Okay? Whenever you have a metal by itself, it's going to change its oxidation state. That's another clue. Don't know what to do with the copper. What do I do with the copper? What do I do with the copper? It's going to change its oxidation state. It's going to react with the nitric acid to form copper 2 nitrate. Okay? But this copper is going to change its oxidation number. So now let's try to balance this thing. We've got to balance the atoms, and we've got to balance the charge on it. And this is where it gets a little sticky. Okay?
2 H2O and 4 hydrogen.
Okay, we'll start there. What do we got?
I think it's balanced.
Is it balanced charge?
No.
No. So it's not balanced on the charge yet.
And then 2 copper for both sides.
2 copper on both sides?
Yes.
Okay. Are we balanced yet?
Oh.
Now I still have a net negative charge.
Yes. Is the copper, the 2+, is it combined with anything?
Yes, it is, but it's a spectator, so we don't have it on there.
What? Is there anything negative on the other side? Is it the nitrogen monoxide?
No. Oh, I'm sorry. There's a negative here, but there is no negative over here.
Right.
No. Nothing. This is not. This is neutral.
Then
That's neutral.
how do we balance the negative?
How do you
Oh, we
balance?
added a negative electron. I mean, not electron.
Okay, so you're thinking now. You're thinking. Can we break this up into two half reactions? Do you think that would be easier to balance it?
I guess.
You want to break it up? Have you ever broken up equations into half reactions?
No,
Yep.
well, I'm sorry, I'm still not understanding like how you cannot include the nitrate with the copper because otherwise you can't balance the number of molecules of like oxygen and stuff.
Yes, we can.
Or like with the charges?
They'll balance. Let's break it up into half reactions. Because if I were teaching this anew, I would teach you to break this up into two half reactions. Okay? So I'm going to erase this completely, but you don't have to cross it off on your paper. Just leave it on your paper. We're going to mesh it here in a minute. Okay, I'm going to leave the copper up there. That's going to be my starting point. So, I have copper reacting with nitric acid. I'm writing this in a different way so that we can see what's really going on. What's my charge on copper here?
Nothing.
Nothing, it's 0. What's the charge on hydrogen?
Positive.
Positive 1. What's the charge on nitrate?
Negative 1.
Negative 1. I know I'm going to go to that. And I know I'm going to get that produced out of it. What's the charge on nitrate or nitrogen here?
2 plus.
2 plus. And this would be 2 minus. Okay? So, let's go back over here. What's the charge on oxygen here? I did the nitrate, but we need to break it down. What's the charge on oxygen anytime you encounter it in nitrogen peroxide? Negative 2. So therefore, what does nitrogen have to be in this situation?
Plus 5.
Plus 5. Okay? Again, that dilute nitric acid tells me that I get this as a product. So what has happened now? Has copper changed its oxidation state?
Yes.
Yes, it's gone from a 0 to a plus 2. Has that been oxidized or reduced?
Oxide.
Go back to the oil rig, right? Oxidation, reduction. Reduction is a gain in electrons, right? Reduction is gain because it's gaining negative charge. So it's being reduced in its negativity, or it's being reduced in its electrical number. Oxidation is loss of electrons. Okay? Oxidation is loss. Reduction is gain. So what has copper done?
It lost.
It lost, so it's being oxidized. So that's one half reaction, correct? So copper at 0 going to copper at plus 2. How do we balance that in a half reaction? What has actually moved?
Electrons.
Electrons, where do they go? Did we add them to the copper, or did we take them away from the copper?
Take them away.
So they would be as a product, right? Okay. Hydrogen is it. We're not going to worry about hydrogen because you're going to get water over there, and hydrogen doesn't change its oxidation. Oxygen hasn't changed its oxidation, but nitrogen has, right?
It lost 3 electrons.
It lost electrons.
Gain 3.
It gained 3. It went from plus 5 to plus 2,
Yeah.
right? So it gained 3 electrons. So our nitrate, we can't pull it out. We've got nitrate, and this is at plus 5, minus 2, going to nitrogen monoxide, which +2 and -2. You don't really need to put the oxidation numbers out there, but I think it helps. I think it helps to see what's going on. Now, did we add or take away electrons from nitrogen?
Added them.
We added them, so they go over here. And notice that I put how many electrons were actually displaced. So in nitrogen, I displaced 3 electrons. In the copper, I displaced 2. Did we ever write equations with electrons in them?
No.
No. So what do we have to do with the electrons?
Cross multiply. Something like that.
Almost. If there are, think mathematically, things on opposite sides, the system of equations where you add equations up, if they're on opposite sides of the equal sign, can we cancel out like terms?
Yes.
Can we cancel out like terms if they're the same?
Yes.
They're not the same. How do we make them the same?
Multiply by the common.
Multiply by the common base. So we multiply this by 3, multiply this by 2. Okay? And then I'm going to rewrite. So I have 3 copper going to 3 copper with a +2 plus 6 electrons. 6 electrons plus 2 nitrate going to 2 nitrogen monoxide. That makes that okay. But now what do I have to do?
Cross out the electrons.
Cross out electrons, but am I balanced yet? No, I forgot to do something.
The oxygen.
I forgot to do something. That's my fault. That's my fault. I forgot to do something. I'm going to erase this. You just put a nice clean line through it, or just leave it, because we're just going to add to it, but I've got to erase it so that I can go back and rethink my process here. I forgot one of the cardinal rules of balancing redox. Can't believe I did that. Have I balanced everything in there?
No.
No. The nitrogen is balanced, right?
Right.
But the oxygens are not. Okay. Balancing redox requires that you add water, hydrogen, or hydroxide ions depending on the situation. This is acidified. How do I know it's acidified? Nitric acid. So I balance oxygen by adding water to the opposite side. So I have oxygen at 3 here. I have 1 oxygen there. How many oxygens am I deficient?
2.
So I add 2 waters. When I add 2 waters to that side, I have now introduced hydrogen into the equation. I have 4 hydrogens over here. Now I have to balance that by adding 4 hydrogens over here. Hydrogen ions.